The first other type of equation that I would like for us to look at are just progress on to the higher degree. We've done x to the first, the linear. We've done the quadratic, x to the second equation. So yeah, let's talk about third degree and fourth degree first of all here. See what we might encounter on that. For example, x cubed plus 4x squared minus 12x, let's let that be equal to 0. How about might we go solving that one? Well, do you see there, first of all, we could start factoring, couldn't we? Yeah, a lot of these first ones anyway, the third, fourth degree ones, we can do a little bit of factoring on them and solve them that way. Now, on factoring, same thing is true for third degree as it is for second degree. To use factoring, we do need one side to be 0, and we've got that. So, yeah, let's use our factoring method here on this. How does this one factor, first of all? Well, we've got a GCF. Yeah, pull an x out, GCF of x. So I'm going to pull an x out. That'll leave me inside here x squared plus 4x minus 12 equals 0. And then very possible, you might need a quadratic formula there, but on the ones we do, they'll be nice. This one, 2 factors, is trinomial, so keeping the x, doesn't this trinomial also factor? I think so. We've got x squared, so that's x and x for it. We've got minus 12 with 4 in the middle. 6 and 2? Yeah, 6 and 2. And it's a minus 12, so one of them needs to be negative. Negative 2, positive 6. Yeah, because that adds to be the 4. Okay, so it does factor up nicely. And then it's just a matter here, each factor equals 0. Just like before. Now we have 3 factors, so you said each one of those equal to 0. This one's done, solved. X is 0. This subtract 6. So we got x is negative 6. Add 2 both sides. So we got x is 2. And we might note there this is a third degree. And how many solutions did we get? We got 3. Okay. Matches up. All right. So here's the next. X to the fourth minus 2x squared equals 0. Well, this one too does factor once at least anyway. What do you got? What's the GCF here? X squared. Okay. So we got an x squared common factor. Both of those have an x squared in them, so I can pull that out. And that'll leave me what? Here, x squared. And then factor off the x squared here, divide it, basically. So I have minus 2. Well, now, though, this doesn't factor. Because, well, you look for difference of squares. Sometimes we'll get those, but no, that one's not going to factor out nicely. So here's what we're going to do with that. What I'm going to do now, since this one won't factor, I'm just going to go ahead and say set equal to 0. The first one, x squared minus 2 equal to 0. Since I do have it factored, I can go ahead. I could have done that here, but I just decided to go ahead and keep factoring until I couldn't factor. Well, I can't factor anymore, so let's go ahead and do that because I do have this times this equals 0, so I can use that little fact right there. All right, well, this was pretty nice. X squared equals 0. About the only way you can do that is x has got to be 0. We could go through a little more there, but it's got to be 0. X has to be 0 for that to be true. Now, this one, maybe a little more work there, but not much. What do I need to do with that one? Yeah, this one, a good one too. It doesn't factor, but a good one good way to do it is to do that square root method. Move this term over, x squared equal 2, right? Then you square root both sides, and you get x equals the square root of 2. However, one fine little catch here is that this side could be what? Plus or minus, yeah. So you got plus or minus the square root of 2 solves that one. So the solution there is plus or minus the square root of 2. And you can round that off if needed, but it's simplified. All right, good question. Why do we only have 3 since it is an x to the 4th? Actually, it turns out, and that's, I didn't go through the whole steps here, but you really, technically, you're solving it this way, and or another way, we can let's think of it this way. That's x times x equals 0, isn't it? So that's x equals 0 and x equals 0, just that they're the same. In other words, this is a double solution. And so that's how we get the 4 out of it. You see that? There's 2 actually 0 solutions. I mean, they're the same, so it's the same, but there are 4 technically there. It's a double solution for 0. Good question, though. All right. Now, here's number 3. 8x to the 3rd minus 22x equals 0. Another type we might come along the way. Same thing, got a GCF, don't we? 2x, that's what I'm seeing. Is that what you're seeing? 2x, GCF, pull that out. And that'll give me 4x squared divided by 2x, so that'd be 4x squared, right? And then what? Minus 11 equals 0. Okay, but again, once again, this doesn't factor. The 4x squared minus 11 doesn't. It's just not going to factor. But we can still then say 2x equals 0, 4x squared minus 11 equals 0. Here we divide by 2, and we've got x is 0. Another one solution. And then here, well, that's the square root method again. In this case, we'd add the 11, and we get 4x squared equals 11. Probably go ahead. Let's go ahead and divide by 4 here. Is that okay? Divide by 4. And so then we'll have x squared equals 11 over 4, square root method. All right, so square root both sides, so we get x equals the square root of 11 fourths. That could be plus or minus square root, though. Now, that's an okay answer. They'll probably, though, want you to do this. Doesn't this square root both the top and the bottom? So that's technically the square root of 11 plus or minus the square root of 11 over the square root of 4. And why would I write it like that? Well, I can simplify that square root of 4, couldn't I? Plus or minus the square root of 11 over square root of 4 is 2. So that's probably the way they'd want you to answer that one. Finish out. Okay? Question? Concern? Is that okay? So far so good? All right. Well, let me tell you about this one. X to the 4th minus 3x squared minus 28 equals 0. X to the 4th minus 3x squared minus 28 equals 0. Well, this one's a slight bit different than the rest of the ones I've done so far. Because does this one have a GCF? No GCF, is there? There's not a common factor because this one doesn't have an x. There's no common factor of x. They all have to have x for it to be a common factor of the thing. And there's no number common in all 3 besides 1. So GCF here is not existent. But I still can factor this one at least once. Do you see that? It is a trinomial, and so trinomials do factor sometimes into two binomials, the way I look at it. Let's try that. Let's try here, do our parentheses, factoring the two binomial thing. The change here is the first term is x to the fourth, not x to the second. But I still can break down x to the fourth, can't I? How can I break x to the fourth? That's going to go here and here. X squared and x squared, right? Yeah, so let's break down the x to the fourth. Instead of just having x squared there, for x and x, I'm doing x to the fourth, so it's x squared instead of normally what we had. Now, the other two, of course, are factors of this minus 28, aren't they? How so there? Well, with minus 3 in the middle, it's 7 and 4, isn't it? 7 times 4 gives me 28, and I can get minus 3 out of that. It's a minus 28, so one of them is minus. The 7's minus, and the 4 is plus, because that'll give me a minus 3 when I add them. Multiplied gives me negative 28, but added negative 3. So that matches the stuff up here. Okay? All right, well, so we've got it factored. Now what? Well, once we have it factored at least once, then we can go ahead and set up each separately equal to 0, can't we? So I do x squared minus 7 equals 0. X squared plus 4 equals 0. And then solve accordingly. Just a couple more square root methods. That's coming in handy a lot here. Add the 7. So I have x squared equals 7. Square root both sides, so I have square root of 7 on this side. X equals square root of 7. This side could be plus or minus, though. Square root of 7. Okay? With me on that. What about this one, though? There's a little something we need to talk about here. On this one, subtract 4. Subtract 4. So x squared equals negative 4. Square root both sides, so I get x equals square root of negative 4, plus or minus, though, on the square root side there. And this is what I want to talk about. What about this square root of a negative? Remember something about that? Remember I, we've got a little number we call I that's equal to what? The square root of negative 1. And I've got that here. If you think about it, I've got the square root, that'll be negative 1 times 4. And so don't I have that I there? And then the square root of 4 is 2. So what's the plus or minus here? 2i, yeah. 2i. Because I've got this, anytime you have the square root of a negative, you've got the I number involved. Is that okay? Problems or concerns on the answer on that one? So there's our four answers. Plus or minus 2i, plus or minus square root of 7. Don't know how often that would come up, but very well might. All right. Anything further on that? Okay, so let's talk about another type here of equations, square root equations. The square root of 5x plus 4 equals 8. Square root of 5x plus 4 equals 8. Okay, well, the idea here is, well, it's similar to the square root method, kind of in reverse, though. What happens is, for a square root equation, if I take this square root equation, do the same thing to both sides, here's what I'm going to do. I'm going to square both sides. Square the right, square the left. Since the square root and the square, they're inverse operations like plus and minus. Subtraction and addition are inverse. Multiplication and division, well, square rooting and squaring are inverse operations, meaning when I have both here, they cancel one another out. The square root and the square, yeah, they cancel one another out. And so I'll wind up with here just 5x plus 4 on the left side. So that's the basic idea. Square both sides. 8 squared, of course, nothing cancel out there. I just have to do 8 squared. 8 squared is 64. So to solve square root equations, square both sides. When it looks like this, of course. Square both sides and the square root and the square cancel out. Then you just have, well, usually just have a regular equation then. This is just linear, so you just subtract 4. 5x equals 60. Divide by 5, and x is 12. Okay? All right, so here's another one. Square root of 3t minus 7 plus 6 equals 10. Well, the catch on this one is, this one's not quite like that one. What's the difference? The 6, yeah. I've got the square root plus 6 on this side, whereas this one had the square root by itself. Well, the deal is, on squaring both sides, you need the square root by itself. For this squaring of both sides to work, you need the square root by itself. So how would I get the square root by itself? Move the 6, which would be, subtract it. Subtract 6, so the square root of 3t minus 7 equals 4. Yeah, then it's set up, square both sides. Square root and the square cancel, so I have 3t minus 7 equals 4 squared is 16. So then I'm going to add the 7. Right? So 3t equals 23, divide by 3. T equals 23 thirds. All right? Okay, one other one. This one might happen on the homework, so let me mention it. 10 times the square root of x minus 4 equals 12. I guess technically we could go ahead and square both sides here. We could also, what is one other thing we could do here? Go ahead and divide by 10. Yeah, we could go ahead and divide by 10. That'd be okay, and get rid of the 10 there, and just get the square root of x minus 4. And then that reduces, 6 over 5? Yeah. Could do that. If we don't do that, square both sides. That one just squares to be 100, and the square root cancels out. But, yeah, that'd be okay to do that. Then I can square both sides now. Square root and the square cancel, so I get x minus 4 equals 6/5 squared. 6 times 6 is 36. 5 times 5 is 25. 36 over 25. Then I just have to add the 4, which is a little bit of an issue, I guess. If we change that to a mixed number, one way we could do it, it's 1 and 11/25 as a mixed number, so that's 5 and 11/25. Or as an improper fraction, 5 times 25 is 125, and then add that to the 11. I get 136 over 25. Either answer. Could do a decimal too. So. lots of different versions of that one. Question?
Okay, so the other one that we didn't do, the other way with the 10, and you square both sides.
If we did divide by 10? Is that what you're saying? Or?
Yeah.
If I did divide by 10 there, yeah.
The way that we didn't do it.
The way, okay, I'll show you. Yeah, the other option here, and sometimes you might have to do this, if we just go ahead and square both sides here, we could do that. It's just that the 10 squares, so that's 100. And then, let's do it this way. You just have this. This is the thing. On the left side, you just have to square the 10 and the kind of separately. This is 100, and then this and this cancel, so we have 100 times x minus 4 equals 100x minus 400, yeah. Yes, it would. Add the 400 and divide by 100. It should get us something close to that. Yeah. I get 544 over 100, which reduces by 4. I know. The bottom would be 25. Is that 136? 544 divided by 4? Hopefully it's 136. I think so. Okay. One other quick one on these. Well, this one isn't a square root. It's a cube root. But what do you think about that? If you have a cube root, are we going to square both sides on it? No, probably going to cube both sides, yeah. With square root, we're squaring because, you know, that matches the root there. Well, a cube root, the power that would match that would be the cube. So, yeah, if you have a cube root, you're going to cube both sides. If you have a fourth root, you're going to fourth power both sides. Now, the thing is here, the first step, though, would be subtract the 2, wouldn't it? Because we can't, if you have a plus or a minus, this is not an option. You can't go ahead and cube both sides for that one. If you have a plus or a minus term here, you got to move that one. Otherwise, it doesn't all work out. Yeah, so we get that. Then we cube both sides. And the cube and the cube root cancel, so we have 3x plus 1 equals 27. Then just solve that out. 3x, subtract 1, so we have 3x equals 26, don't we? Divide by 3. 26/3. Leave that. Any questions further on solving other types of equations before we move on? Question, concern, comment?